Flowcharts. A program is an algorithm written in a specific language that is understood by and runs on a computer. Some examples are software programs, websites, and video games. Every algorithm contains some combination of three control structures. A control structure is something that determines the order that statements are executed and/or the direction to go. Clarity and readability are important considerations when expressing an algorithm in a programming language. A code statement is a part of program code that expresses an action to be carried out. The three control structures are below. Sequence, a series of precise statements. Selection, where the algorithm can select one of two or more paths. Repetition, or iteration, where an algorithm can repeat a sequence. They are the basic building blocks of algorithms. We will begin to use flowcharts to help us understand these control structures and also draft our programs. In order to function properly, computers need precise sets of instructions that can only be interpreted one way. They need algorithms. The more complex algorithms become, the more programmers need to organize the flow of them so that the simple binary choices are recognizable to them when writing the actual code. Flowcharts are diagrammatic representations of algorithms, processes, or workflow. They use various boxes, connected with arrows to show order, to visually represent the steps that the algorithm will take prior to actually writing it. Flowcharts are just one example of how computer programmers plan programs before writing them. The first control structure we will look at is sequence. We often give instructions using sequence as it shows procedures in a step-by-step format. The flowchart below uses arrows to show the order in which each step must occur. The oval represents the start or end of the algorithm, while each rectangle represents a step or process. The programs we wrote in the first unit each had a sequence. For example, remember this one? A equals 1, print A. A equals 2, print A. A equals 3, print A. It prints 1, 2, 3. How could you represent this sequence in a flowchart? Does your flowchart look like this? It's okay if you used all rectangles. Flowcharts use different shapes to represent different but universal meanings. The parallelograms represent input or output. The chart below describes the most common flowchart shapes. Ovals represent the start or end of the algorithm. Rectangles represent one or more steps or processes. Diamonds represent conditionals or decision steps. And parallelograms represent input or output. Are you noticing how algorithms could get very long and repetitive? This is where repetition, or iteration, comes in. Iteration is when an algorithm repeats steps, rather than listing them sequentially over and over. The flowchart below shows iteration. Notice we will use the diamond to represent whether the procedure will be repeated. If it's not going to be repeated, it'll exit the iteration. Let's take a look at a classic example, the instructions on a shampoo bottle. The directions are to wash, rinse, repeat. Sequentially, that would be represented like the flowchart on the right. What's wrong with this? It's a bit redundant. You have wash and rinse in there twice. What if the instructions for this specific shampoo were to wash and rinse 4 times in a row? That would look like the flowchart shown to the right. But what about 10,000 times? That would be a very long and redundant program. However, computer programmers are constantly asking their computers to run repetitive tasks of thousands of steps. You might be saying, is there a better way? There sure is. Iteration. What if we wash, then rinse, and then ask the question, should we repeat those steps? That would look something like this. But notice any problems with this? Go through the algorithm step by step. First we wash, then we rinse. Next, repeating takes us back to the top, and we begin again. We wash, then rinse. But when do we stop repeating? We don't necessarily want to wash and rinse our hair forever. Iterations need something that was not considered before with sequence: conditions. A condition is something tested before the iteration runs each time. Sometimes it's actually tested after the iteration runs. It will only run if the condition is true or yes. This way, when the condition eventually is false or no, the iteration will end. In this case, when would be a good time to stop washing our hair? When your hair is clean. So we want to continue the iteration as long as your hair is dirty. So here we'll ask, is your hair still dirty? If you answer yes, you'll go back to the wash step.